Keep rolling, rolling, keep rolling, rolling. All the boys in the hood. Oh, whoa. Let's see. This is section 9.1, developing formulas for triangles and quadrilaterals. In this section, we're going to learn some different formulas that you're going to have to use. State assessment's going to have a lot of these formulas on it. Make sure you learn this. Make sure you always read the objective, read the why, answer number 5, and have the title in your notes. Let's roll. Alright, let's roll past this page. You can read that. And the first thing we're going to do is talk about, well, the area of a rectangle. The area of a rectangle we all should know is base times height. And we're going to see how that is going to derive the formula for a parallelogram. So the area formula for a parallelogram is going to be similar to that of a triangle. And if we click here and notice, if we slide this piece right over to the other end, it just forms a rectangle. So a parallelogram is going to be the exact same formula as a rectangle, except for this is going to be the height from one vertex down straight, forming perpendicular to the other side, and then the base is going to be either the top or the bottom. So area formula for a parallelogram, same as the rectangle, base times height. Alright, I think we got a few examples with that real quick here. Let's see, we've got this parallelogram we're supposed to find the area of, and we're given the base is 11, we're given this little length here is 30 centimeters, we're given this, which would be the same as this length here, is 34, so it looks to me like we're going to have to use Pythagorean to figure out what the height of the parallelogram is. So we're going to call this x. We're going to say x squared plus 30 squared, wow, my handwriting's getting better all the time, isn't it, equals 34 squared. So let's see, x squared plus 900 equals, and let's go ahead and break out the old calculator real quick here, handy dandy calculator, and we've got in the calculator we got 34 times 34, bam, looking good. Now we got 1156 that we're going to subtract the 900 from, and that's going to give us 652. So x squared is equal to 256, so we're going to have to take the square root of 256, and that's going to give us 16 for x. So now we know the height is 16 and the base is 11, so base times height, 16 times 11 is going to give us 176, and in any area it's always going to be square units, so millimeters squared in this case. Alright, next example says the height of a rectangle in which b is 3 inches, the base is 3 inches, and the area is equal to that. So we're going to have area is equal to base times height. So we're going to fill in the area is 6x squared plus 24x minus 6 is equal to our base, which is 3, and then times the height. Alright. So all we're going to do here is divide by 3. We're going to divide by 3 all the way across here and just simplify this, and that's going to be what our height is equal to. So that's going to be 2x squared plus 8x minus 2 is equal to our height. So, and that would be inches. That's what we'd want to probably put as the units on that. Alright. Let's see. This will be a little out of order here. Area addition postulate is that the area of a region is sum of the areas and its non-overlapping parts. Let's see, looks like now we have the end of those examples right here. So like I said, this got a little out of order for some reason. I'll need to fix it for the regular geometry class. Let's see, the perimeter of a rectangle in which the area is equal to that, and it looks like we're given the base is 21 here. So we got area is equal to base times the height, and we got the base is 21. So we're just going to go ahead and quickly solve this for the height. Let's see, it's 79.8 x squared minus 42. So we're going to have to divide by 21 on both sides. So let's see, let's take the 79.8 and divide that by the 21. That's going to give me 3.8 x squared. And then 42 divided by 21 is going to be a 2. So now I've figured out what my height is. So now I'm going to say the perimeter of a rectangle is equal to 2 times the base plus 2 times the height. Well, I know that the base is 21, so I'm just going to plug that in right there. So that's going to end up to be 42. And then I got plus 2 times the h, which is what I have sitting right over here, which is 3.8 x squared minus 2. Now all we have to do is a little bit of simplifying here. So I'm going to get just a little bit of room here. 42 plus, let's see, what's that going to be? 7.6 x squared minus 4. So now I can combine the negative 4 with the 42, and that's going to be a 38. I'm going to slap the 7.6 x squared down in front, and I have the perimeter, and it looks like that's in centimeters. Perimeter is just in singular units, so like centimeters, meters, or miles, or feet. Alright, there looks to be the regular geometry classes assignment. Let's roll on. Notice that the triangle is just half of the rectangle, so we take the area formula for a rectangle and divide it by 2, or multiply it by half would be the same thing. So let's move on here. The trapezoid. On the trapezoid, notice that it's broken apart into a rectangle and then 2 triangles. So the formula, let's back it up, for the trapezoid would be the base 1 plus the base 2 times the height, all divided by 2. Alright, find each measurement. Looks like we're given base 1, base 2, and the height, so this one should be a pretty easy one. All we have to do is plug it straight into the formula. So let's write the formula down real quick. B1 plus B2 times the height, all divided by 2. So now let's substitute in. I got 8 plus 5 times 6.2, all divided by 2. So that's going to be 13 times 6.2. Let's go down to handy dandy calculator. It'll be 80.6 divided by 2 would be 40.3 inches squared for the area of that trapezoid. Alright, let's scroll down a little bit, and I think we got looks like a triangle area problem. The area is given to us. Remember that area is equal to 1/2 base times height. So the area is 15x squared is equal to 1/2 times b times 5x, and we're solving this, it looks like, for b. So I'm going to have to, let's just multiply by 2 right off the bat to get rid of this 1/2. So when I multiply by 2, the 2's will cancel here, and that will be 30x squared is equal to b times 5x. So it looks like I just have to divide by 5x. So one of the x's will disappear here. The 5 will go into 36 times. So it looks like 6x is left, and that must be equal to the base. Bam. Alright, let's roll on here. It looks like we've got a trapezoid problem again. Looks like we're looking for base number 2. We're given the area and we're given the other base. So let's go straight to the formula here. We've got 231 is equal to my base 1, which is 23, plus my base 2, which we don't know, we're looking for that, times the height of 11, all divided by 2. So I think I'll just multiply by this 2 right off the bat to get rid of that. So 462 is equal to 23 plus B2, all times at 11. So let's get rid of the 11 next by dividing by it, and let's happen to see if we get lucky, and that divides out of there. So 462 divided by 11, bam, 42, we did get lucky. So 42 is equal to 23 plus base 2. So I gotta subtract the 23 right over here, and it looks like what? Is that 19 is equal to my base 2. Bada boom, bada bang, we're done. Alright, looks like the area formula for the kite, we multiply the two diagonals and we divide it by 2. If you notice, kite just is divided into two triangles here, so we just have to add the two areas of the two triangles. We get that by 1/2 d1 times d2. We probably will, oh, we get the same thing in a rhombus, by the way. Rhombus has the exact same area formula. So we should have a couple of examples right here. Here's one of them. It looks like we're looking for the length of the other diagonal. So we got 48 for the area is equal to 1/2. The first diagonal looks to be 8 all the way across, and then the x is the label for the other diagonal. So half of 8 is 4, so we'd have 4x is equal to 48. So when I divide by the 4, it looks like we'll get 12 is equal to x, and that would be feet. Alright, next one here, it looks like we've got a d2 of a kite in which d1 is equal to 14 and the area is equal to that, so it looks like the same type of problem. 238 is equal to 1/2 of my d1, which is 14, times my d2, which I'll be looking for here. So half of 14 is 7, so if I divide by 7 right here, let's again see if we're going to get lucky. 238 divided by 7 equals 34. So 34 actually is going to be our D2. It looks like we're in inches this time, so I'm going to label it inches. Bam. Alright, the area of the rhombus right here. So we know we need to multiply these two together and take half of it. So area is equal to 1/2. Multiply the 14x minus 6 times the 8x plus 7. By the way, it doesn't matter which one you call B1 and B2. I did it this way because I'm going to take half of the 14 and 6, and that's going to come out nice and even. So 7x minus 3 right off the bat for me, and 8x plus 7. Now I've got to FOIL this out, so I got to multiply the 7x times both terms over here, so that's going to be 56x squared, and then plus 49x. And then let's see, I'm going to have the negative 3 times the 8x, which is negative 24x, and then minus 21. So I'm going to combine the middle two terms here into 25x minus the 21, and that's 56x squared. Bam, we've got the area. Probably should label it something, but we don't have it, so I'm just going to put u squared for units squared. Alright, regular geometry students, there you go. We're going to cruise on here. Just some random examples thrown in at the end. Looks like we're going to be able to wrap it up here. This Mr. Lane signing off. Oh, secret word, almost forgot. Let's go note. Like a secret note. So, just note for the secret word today. So, Mr. Lane signing off from OHS High School. Catch you on the flip side.